right, so chapter 5, section 2 is the natural logarithm with integration. We did derivatives in 5.1, now we're going to do antiderivatives in 5.2. And you have seen this rule, although you didn't see it written this way. When you actually, well, you saw the first one, the differentiation rule written this way. When you have a function, natural log of x, then its derivative is 1 over x. And then the reverse of that then is that if you have the antiderivative of 1 over x, again we saw this last time, what is the antiderivative of 1 over x? Natural log of x. And of course it's plus c. Now the one difference here is that it's actually going to produce, well maybe I should do it in the same color. It's actually going to produce absolute values around that natural log because we can't use all the values of x. At least not as it was defined on the left-hand side. So anytime we take the antiderivative of 1 over x, it produces those absolute values. Okay? So we want to remember those absolute value signs when we do antiderivatives. Excuse me, and we're going to do a few. All right? So we've got the antiderivative of 5 over x. What is going to be the antiderivative of 5 over x? 5, natural log of the absolute value of x plus c. It's pretty easy, right? We can handle that. Okay, going to get harder. Now what happens when we have 1 over 4 minus 3x? All right, so this is a U-substitution. It's a fairly simple U-substitution, so the more proficient you get at it, you may not actually show this step, but you probably haven't done U-substitution in several months, most of you. So let's take it slowly. So what would I let u be? The denominator, 4 minus 3x. What do I do next? Du. Good. I need the derivative of that. What is the derivative of 4 minus 3x? Negative 3. Dx, actually, right? All right, so then I'm going to change this expression. This expression is going to change into the integral of what? 1 over u. Du. Seems to be missing something still, though. That negative 3's got to come into play somehow, right? Because it wasn't in the original expression to be eliminated with. This is how I tend to think of it. I tend to think of this dx as being something I'm going to solve for. So if I move this negative 3 over to the left-hand side as a negative 1/3. What that tells me is that the dx in the original problem where I had dx needs to replace by 1/3 du. Not just du, but 1/3 du. And I don't have to put the 1/3, negative 1/3, like attach it to the du. I can put it in front of my function, or in my integration if I'd like, just to make it a little bit cleaner. But there is going to be a negative 1/3 there because the dx actually equals negative 1/3 of the du originally. Okay, so then I'm going to have negative 1/3 as part of my solution. What's the antiderivative of 1 over u? Natural log of the absolute value of u plus c one more step. That's right. The original problem started out in terms of x. So the solution needs to be in terms of x as well. So I need to replace that u back with what u actually is equal to in terms of x. So this is negative 1/3 natural log of the absolute value of 4 minus 3x plus c. Does that make sense? Okay. Let's do another one. We've got x squared minus 2x over x cubed minus 3x squared. What do you want to try? Okay, that sounds good. Then what? Take the derivative. Du is going to be, and then dx. Okay, that doesn't quite look like the numerator, but it could. How could I change it so that it does look like the numerator? Right, factor out of 3, right? It's exactly 3 times as much. So if I rewrite this or rethink about it this way, I've actually got 3 times the numerator. And I can do exactly what I did just a moment ago and write this as 1/3 du equals x squared minus 2x dx. So in essence, what I'm going to do is this this x squared minus 2x dx, all of that is going to be replaced by the 1/3 du. And I tend to write mine in front, the coefficient there, that 1/3 in front. You don't have to, but I do. And then that means I've got a 1 on top, and there's the du. So that's the piece that I was just referring to. 1/3 is there, and the du is there. So these pieces replaced what was in the circle. And then what goes in the denominator? U. Then I can take an antiderivative very easily. So what's the antiderivative?
1/3 natural log absolute value of u plus c.
Perfect. But just like on the last one, I can't stop there, right? It's going to be 1/3 natural log of what? X cubed minus 3x squared. And then plus c. All right. I want to do one more, but I want to go out of order. I want to do E. We'll come back to D next time. Remind me if I forget that I skipped D. D is a little bit more involved, and it's actually a different method than we've just been using. But E is going to fall very nicely into our method that we've just been doing. All right, so the last 2 problems have both used what kind of integration technique? U-substitution. And this one will as well. Now, the problem is, when you look at this one, that you're trying to take an antiderivative of a natural log. And at this point, and at the point in the entire semester, we don't have a closed form for the antiderivative of natural log. We don't have one. So that means I can't take the antiderivative of natural log without some much higher techniques than we've just discussed, okay? So what that means is that when I'm doing my U-substitution, that one must be U, because that's how I'm going to get it to go away. Does that make sense? So this is going to be the natural log of the x part, be the natural log x part. So then what is the du? Good. 1 over x. So the derivative of the natural log of x is 1 over x dx. Why in the world is that nice? That's going to cancel that x in the denominator, isn't it? You can think about this function as being written as the natural log of x squared times 1 over x dx. That's the same thing, isn't it? So this piece here at the end is du. I've got an integral, and what goes in between them? U squared, right? Does that make sense? So at the moment, if you see a problem that has natural log in it and it's asking you to take an antiderivative, the only option you've got is U-substitution where U is natural log x. That's just your only ploy. That's it. No other choices. Now, what is the antiderivative of U squared?
1/3.
Okay, so either 1/3 U cubed or U cubed over 3. Plus c, right? Then what?
Plug in u.
Yeah. Substitute in. So this is 1/3 times the natural log of x, quantity cubed. Make sure that natural log of x is in parentheses because that means something different. If you leave those parentheses off, it's going to look like the natural log of x cubed instead of the natural log of x, quantity cubed. You guys with me? Plus c. All right, We're going to pause there today, and we're going to do one more